along the spine of the Scottish Highlands, running northeast to southwest across an ancient and still shifting landscape. There is a fracture in the rock that predates almost everything else visible on the surface of the earth in that part of the world. The Great Glen Fault is not a gentle feature. It is a displacement, a place where two enormous masses of rock were sheared apart and slid against each other over millions of years, moving by as much as 100 kilometers in total, leaving behind a long straight valley, so geometrically precise that it still looks, even from a considerable height, less like a natural landform than like a cut made deliberately into the earth. The hills rise sharply on both sides, angled and parallel, following the fault's line with the kind of regularity that belongs more to architecture than to erosion. At the base of the valley, between those hills, the water settled. Loch Ness occupies that fracture. The loch did not carve the valley it sits in. The fault did that, over geological time so vast that the human mind loses its footing trying to hold it. The water arrived much later, filling the basin left behind when glacial ice retreated from the Great Glen approximately 10,000 years ago. What it filled was already one of the most significant geological features in the British Isles, a tectonic wound running for the length of the highlands, narrow and straight, with walls of ancient metamorphic rock on either side that had been polished and scored by the ice before it pulled away. The loch that formed in that space stretches approximately 37 kilometers from its southwestern end near Fort Augustus to where the River Ness carries its outflow northeast toward Inverness, and for most of that length, it averages only about 1.5 kilometers in width. It is, in every dimension, a place shaped by forces that operated on a scale, and a time scale entirely removed from anything visible on its calm surface on an ordinary afternoon. The water it holds is a measure of its depth. The loch contains an estimated 7.4 cubic kilometers of fresh water, a figure that carries more weight when it is held against the combined total of all lakes, reservoirs, and freshwater bodies in England and Wales, which the loch's volume exceeds. That combined total, drawn from every standing body of water across 2 entire countries, is less than what occupies this single narrow basin in the Scottish Highlands. The surface of the loch covers a relatively modest area, averaging that 1.5 kilometer width across its 37 kilometer length, and from the road above the western shore, the water looks entirely manageable. A highland loch, dark and cold, familiar in the way that highland lochs are familiar to anyone who has driven through that landscape. The depth beneath that familiar surface is something else entirely. The basin floor of Loch Ness reaches depths in its central sections that exceed 220 meters in places, and the transition from the shallows near the shore to those depths happens with a speed that the surface gives no indication of. Sonar surveys conducted at various points over the past several decades have confirmed near-vertical underwater cliff faces that drop from just a few meters below the surface to depths of 150 meters or more in a single continuous descent, the rock walls descending sheer and unbroken through the water column. A swimmer at the surface near certain points on the western shore is separated from a drop of over 200 meters by only the width of a few body lengths of horizontal distance. The bottom of that drop, where it levels out into the loch's deepest basin sections, is covered with sediment, fine organic material, particles of peat, and decomposed matter accumulated over the 10,000 years since the glaciers retreated and the water first arrived in the valley. That sediment lies undisturbed in the deep sections of the basin. It has been undisturbed for a very long time. The floor of Loch Ness near Invermorston, on the western shore, roughly midway along the loch's length, sits beneath one of the most precipitous of these underwater slopes. From the road above the water, looking down toward the loch on a still morning in autumn, the surface is dark, nearly black in certain lights, the color of deep water beneath an overcast highland sky. When the air is calm enough, the hillside on the opposite shore reflects in that surface with a clarity that seems almost photographic. The dark shapes of spruce and larch, and the lighter patches of exposed rock inverted in the water. The reflection so precise that the two images, the real hill and the reflected one, merge into a single vertical composition that extends downward into the loch with no visible boundary between them. The surface from that distance looks still and shallow, comprehensible, the way a puddle is comprehensible. Below that reflection, within a short distance from the shore, the bottom drops away. The sonar traces that describe those slopes show the descent beginning almost immediately and continuing near vertically for the full depth of the loch. What the geological surveys have established about the basin floor is that it is not uniform. There are sloping sediment shelves at various depths, broad flat sections where the accumulated material of 10,000 years has settled in horizontal layers, and then the deepest sections of the main basin where the floor levels out at its greatest depth. This geometry, the vertical walls, the shelves, the deep flat basin between them, was first documented in detail, not by remote instruments, but by direct observation. In 1969, the Vickers Pisces manned submersible descended into Loch Ness as part of a systematic effort to document what the basin actually looked like. The submersible was a compact deep-diving vessel, and its crew carried powerful artificial lights designed to illuminate the water around the hull during the descent. Those lights in the water of Loch Ness did not behave as they would have in clear water. The Pisces descended through the first meters of the water column in conditions that were manageable, the surface light filtering down through the upper levels of the loch before fading as depth increased. The walls of the basin were visible to one side as the submersible went deeper, the cliff face of ancient rock, scored and darkened, dropping away alongside the vessel as it descended. And then, in the deeper sections, the suspended particles in the water began to absorb and scatter the artificial lights back toward the hull, reducing the effective visibility to a handful of meters in any direction. The crew could see the instruments. They could see portions of the cliff wall immediately beside them, the basin they were descending into. The broader space of the loch at depth was invisible, not because there was nothing there, but because the water itself became impenetrable at that depth, in a way that no amount of artificial illumination could overcome. What they documented, the sheer walls, the sloping shelves, the deep sediment floor, was documented at close range, moving through darkness, the instruments recording what the lights could not show. The particles that absorb those lights are peat. The water that drains from the surrounding highland landscape into Loch Ness carries peat particles with it, fine organic materials suspended throughout the water column, rather than settling out of it, and those particles are present at every depth, from the surface to the bottom of the basin. Peat is the accumulated and partially decomposed remains of organic matter, mosses, grasses, heather, the plant life of the highland hills across centuries of growth and decay, and it stains the water the color of weak tea close to the surface and the color of dark timber at depth. The concentration of suspended peat particles in Loch Ness is significantly higher than in most freshwater bodies, a function of the particular drainage area the loch draws from and the character of the highland soil that surrounds it. In clearer water, artificial lights can illuminate significant distances. In Loch Ness, the suspended peat functions as a medium that absorbs and scatters light within a few meters of its source, reducing visibility at depth to something close to nothing, regardless of the power of the illumination. Below 30 meters, the documented visibility in Loch Ness approaches zero. This is not an approximation. Researchers conducting underwater investigations in the loch have reported this consistently across different equipment and different survey periods, and the figure is well established in the scientific literature on the loch. 30 meters is not very deep. It is less than the depth of many municipal swimming pools when measured in standard units, less than the altitude of a large tree. A freediver could, under controlled conditions, reach 30 meters on a single breath. Below that depth in Loch Ness, an observer with the best available artificial lighting cannot see more than a few meters in any direction. The rest of the basin, the remaining 190 or more meters of water column, the cliff walls descending below that point, the sediment floor at the bottom, continues below that threshold of visibility in complete and permanent darkness. The temperature at depth in Loch Ness is as stable as the darkness. From the surface to approximately 20 meters down, the temperature of the water varies with the seasons, warmer in summer, cold in winter, a thermocline forming in the warmer months where the surface layer heated by summer sunlight meets the colder water below. Below that thermocline, the water remains at approximately 5 to 6 degrees Celsius year-round without significant variation. The loch does not freeze, even in the coldest highland winters, because the volume of water at that temperature is too large to be brought down to freezing point by surface conditions alone. The deep water of the loch maintains its temperature with the stability of geology rather than the variability of weather, cold and uniform, consistent across decades of measurement in the same way that the rock walls of the basin are consistent, something that simply persists, unchanging, beneath the surface fluctuations of the world above it. This temperature becomes meaningful when it is placed alongside the dimensions of the basin. The deep water of Loch Ness exists at 5 to 6 degrees Celsius in near total darkness, below a visible boundary, in a space that no human diver can safely reach and that even instrumented systems struggle to fully survey. The water column between the surface and the deepest sections of the basin represents, in practical terms, an environment that has been measured and charted, but not directly seen through in any comprehensive way. The sonar profiles, the traces of sound moving through water, the echoes returning from walls and floor, and anything in between, give shape to the basin's geometry in ways that the human eye has never been able to confirm directly. What the sonar measures is real. The space it describes is real. The relationship between those measurements and the actual contents of the basin has, in the deepest sections, never been directly observed. The loch's surface above all of this is, on a calm day, entirely ordinary. The water catches the light in the way that water does. The hills are reflected in it when the air is still. Boats move across it. The road runs along its western shore for most of its length, and drivers pass alongside it every day in both directions, the water visible through the trees or in the gaps between roadside walls, dark and undisturbed and familiar. The surface gives nothing away about what is beneath it. It does not announce its depth. It does not indicate that 30 meters below the calm reflections, the water becomes effectively impenetrable to observation, or that beyond that threshold, the basin continues downward through darkness and cold to a floor that has been accumulating sediment since the ice retreated and the valley first began to fill. The Great Glen Fault that created this basin is still geologically active in a minor sense. The rock masses on either side of the fracture continue their slow relative movement, measured in millimeters per year, the kind of motion that only geological instruments can detect, and that will not produce any visible change in a human lifetime. The loch sits in a crack that is still, technically, a crack, a displacement in the Earth's crust that is ongoing at a rate too slow to perceive, but continuous in the same way that the accumulation of sediment on the basin floor is continuous, grain by grain, year by year, in the cold and in the dark. The geology of the Great Glen is the geology of deep time, and the loch is one of its more visible features, visible from the surface, that is, where the water reflects the sky and the hills and the occasional passing vehicle on the road above the western shore. Below the surface, the dimensions are different, what the 1969 Pisces expedition documented, systematically, with instruments, with direct observation, where the conditions permitted, was a basin more complex and more difficult than the sonar profiles alone had suggested. The cliff walls seen up close were not uniform surfaces. They had texture, they had variation, they descended in ways that the two-dimensional sonar traces had only partly conveyed. The sediment shelves at various depths were extensive, broad surfaces of accumulated organic material that the submersible moved above at close range, the lights picking out the surface of the sediment in the small circle of visibility available to the crew. The deepest sections of the basin, where the floor leveled out below the main descent, were reached and documented. The crew saw what was there. Within the few meters of visibility the suspended peat allowed. The rest of the basin floor, beyond those few meters, remained outside the reach of what the lights could illuminate, measured by instrument, located on the profile, but not seen. The sediment on that floor is extraordinarily fine. Material of that particle size settles slowly through the water column, taking days or weeks to descend from the surface to the bottom, and it accumulates in layers that preserve within them a record of what has fallen through the water above them over thousands of years. In the deep basin sections of Loch Ness, the sediment layers represent an unbroken archive going back to the time when the glacial meltwater first gathered in the valley. Pollen grains, organic fragments, the mineral particles carried in by streams from the surrounding hills, all compressed into a column of fine material that sits in the cold and the dark and does not move. Nothing disturbs it. The water above it is too cold and too still at that depth for any significant current to develop. The sediment rests in absolute stillness and absolute cold, 200 meters below a surface that the autumn sunlight touches every morning and that the road runs alongside for 37 kilometers, familiar and dark and ordinary. The loch's depth varies along its length in ways that the overall dimension of 220 meters does not fully convey. The deepest sections are not distributed evenly across the basin floor. There are points where the depth increases significantly beyond the general average, and other sections where the floor rises toward the shallower basin geometry near the loch's ends. Near the southwestern end, where the loch narrows toward Fort Augustus and the river Oish feeds into it from the south, the water becomes shallower and the character of the basin changes. Near the northeastern end, where the river Ness leaves the loch toward Inverness, similar shallowing occurs. But in the main body of the loch, the central basin, the depth is consistent and severe, the walls dropping away on both sides, and the floor far below the surface in a geometry that the narrow width makes counterintuitive. A body of water only 1.5 kilometers wide, holding water over 200 meters deep, the proportions of something more like a fjord than a conventional lake. The Great Glen Fault runs straight, and the loch runs with it. If the valley is viewed from any significant height, from the hills above the eastern shore, or from the air, the straightness of the loch is one of its most immediately striking features. Most natural water bodies curve and meander. shaped by the less regular processes of erosion and drainage. Loch Ness runs straight as a road for its entire length, the northeastern and southwestern ends visible simultaneously from certain elevated points, the hills parallel on both sides, the water between them a single continuous dark shape, following the fault line with geometric precision. The fault created that straightness. The fault is the reason the basin exists at all, the reason it is narrow, the reason it is deep where it is deep, the reason the water that gathered in it after the glaciers retreated found such an extreme and regular form. The loch is a geological artifact as much as it is a body of water, a consequence of forces that operated over millions of years and produced, among their other effects, this particular volume of cold, dark water in this particular shape in the Scottish Highlands. The Western Shore Road, the AI-82, follows that straight line closely enough that for much of its length, the loch is visible from the driver's side window. The road was constructed in a form that permitted significant vehicle traffic beginning in the early 1930s. Before that, access to the loch side was more limited, and the number of people who spent time looking at the water's surface from that angle was correspondingly smaller. The road brought observers. It brought a constant moving presence along the shore, people passing with the loch visible beside them at varying distances, the water occasionally showing its surface from close enough range that what moved on it or in it could be seen in some detail. The construction of that road is one of the documented structural facts about the loch and its surrounding landscape, a change in the physical access to the shoreline that altered, in practical terms, who could see the water and how often. From the road, looking northeast on a clear morning in September, the loch's surface is a long dark corridor disappearing toward Inverness. The hills on both sides hold the water between them, their slopes covered with a mixture of commercial forestry and open heather moorland, the tree line irregular against the sky. The water below is still on calm mornings, and on still mornings, the depth of it is entirely invisible from above. It looks, at those times, like a flat surface, like something that has extent in two dimensions, length and width, but that does not have the third dimension it in fact possesses in such an extraordinary measure. The near vertical cliff faces below the surface. The long descent through cold and darkness to the sediment floor, the near zero visibility below 30 meters. None of this is apparent from the road. The surface is the surface, and it gives nothing of what is beneath it away to the casual observer passing alongside it in a car. The loch has been measured carefully at various points and with improving technology over the past several decades. The measurements agree on the essential dimensions, the length, the maximum depth, the general profile of the basin floor, the character of the cliff walls in the deeper sections. What the measurements also agree on, consistently and without exception, is that below a certain depth, the instruments can describe the basin, but nothing can see into it in any useful sense. The sonar can measure the distance to the bottom. The thermometers can record the temperature at various depths. The water chemistry can be analyzed from samples drawn up in sealed containers. The sediment can be cored with an instrument lowered on a cable, and the core extracted can be studied in a laboratory. These methods have told researchers a great deal about the geometry and the physical character of the loch. The methods that depend on light, cameras, video systems, direct visual observation from a manned submersible encounter the suspended peat within a few meters of their source and can go no further. The Vickers Pisces crew, descending through the loch in 1969 with their powerful lights illuminating the cliff face, a short distance to their side, were working inside this constraint. Their instruments knew where they were in the basin. The sonar told them the distance to the wall, The distance to the floor, the geometry of the space around the hull, their eyes, and the camera systems operating with them could see a small sphere of illuminated water within which the peat particles were visible as a kind of floating interference, and beyond that sphere the rest of the basin extended in darkness that the lights only partially reached before being absorbed. They moved through the loch's deep sections in that condition, knowing where they were by instrument, seeing very little of what was around them directly, the basin present and measured, but not visible in any comprehensive way. When they ascended, and the submersible was recovered, and the crew reported what they had seen and documented, the conclusion that emerged from their observations was straightforward. The basin was physically more complex and more varied than the two-dimensional sonar profiles had suggested, and the conditions at depth were as inhospitable to direct visual survey as the pre-dive data had indicated they would be. In the years following that expedition, sonar surveys of increasing sophistication have added to the profile of the basin without fundamentally altering the conditions described by the Pisces crew. The geometry of the cliff faces, the extent of the sediment shelves, the depth of the main basin floor, all of these have been refined by subsequent measurement. The peat particles remain in suspension. The water remains at 5 to 6 degrees Celsius below the thermocline. The visibility below 30 meters remains close to zero. These are not changeable features of the loch. They are the consequence of its geology and its drainage area and its thermal properties, and they persist regardless of the sophistication of the equipment brought to investigate them. The loch can be measured. It can be described in considerable geometric detail. What it cannot be, in its deepest and darkest sections, is seen through, on an autumn morning near Invermoriston, on the Western Shore Road, a few hours after sunrise. The loch surface is the color of old pewter when the light is flat and overcast, a shade that is neither gray nor black, but something between them, the color of very cold still water under a sky without much blue in it. From the road above, the water extends away to the northeast and the southwest in its long straight corridor, the hills holding it steady on both sides, the surface undisturbed. It looks like what it is on its surface, a highland loch, ancient and cold and unremarkable in the way that very old things and landscapes can be unremarkable until their dimensions are considered carefully. From the road, the near shore is close. The far shore, a kilometer and a half away across the water, is visible and clear in the still morning air. The depth between those two shores, beneath that flat pewter surface, descends through peat-dark water and near vertical rock walls, through the boundary where the artificial lights of the Pisces crew scattered back from the suspended particles decades ago, past the thermocline where summer warmth gives way to the permanent cold, to a floor covered in fine sediment that has been undisturbed since the first meltwater gathered in the valley 10,000 years ago. The surface shows none of this. The surface is the surface, calm and dark and still, the far hillside reflected in it with perfect clarity, the water appearing to have extent in only 2 dimensions, while the third dimension continues downward in the cold and the dark to depths that have been measured, recorded, and that no light has ever properly reached. The measurements are precise. The instruments have returned reliable data across decades of careful survey. The geometry of the basin has been described in detail, sufficient to produce charts and profiles and 3-dimensional models of the floor. What the measurements describe is a space that extends far beyond the reach of any light source deployed within it, a basin whose deepest sections have been located by sound and temperature and chemical analysis, but whose contents below the threshold, where peat absorbs the artificial illumination within a few meters of its source, remain in a darkness that the instruments can locate but cannot illuminate. The loch has been measured. It has not been seen. Those two things are not the same, and the gap between them is not a small one. On the morning of April 21st, 1934, a photograph appeared in the Daily Mail. It occupied a modest portion of the page, a rectangle of high contrast newsprint, dark tones, a suggestion of open water. Beside it, the name Robert Kenneth Wilson was printed in the kind of matter-of-fact type that newspapers used for attributed testimony. Wilson was a London gynecologist, a professional man, a respectable source for a publication that had staked considerable editorial attention on the question of what was or was not living in a Scottish loch. The photograph showed, or appeared to show, a long curved neck rising from the water's surface, a small head turned slightly, the whole figure dark against what might have been rippled water or might have been sky. The image was small enough and the newsprint coarse enough that its details resolved only at close reading distance. Readers held the paper in morning light, in kitchens, on trains, and looked at it. Most of them found it convincing. What makes that morning worth considering is not what the photograph showed, it is what the photograph did. The particular thing that happens when a legible image arrives at exactly the moment a public has been primed to receive it. The Daily Mail had already invested significantly in the Loch Ness question. The newspaper had sent investigators north. It had published accounts of sightings, testimonies, reports from the lochside. It had already attached its name to a story it wanted to continue telling. And here, in April, was the story's natural conclusion: a photograph, a doctor's name, an image that could be cut out and kept, referenced, reprinted, handed across a table. The photograph arrived into a space that had been carefully prepared for it, and it filled that space completely. Wilson himself gave very little away. He described having been driving near the loch when he noticed something moving in the water, and having stopped to take several photographs with the camera he happened to have with him. He expressed only modest interest in the result, maintaining a professional distance from the excitement the image generated, which may have been the most effective thing he could have done in terms of preserving its credibility. A man who had rushed forward to sell the story might have invited skepticism. A man who appeared mildly inconvenienced by the attention seemed, by contrast, entirely reliable. His reticence was read as integrity. The photograph passed through the culture on the strength of his name. It would be 60 years before a different name entered the record. Christian Sperling was 90 years old in 1994, and he gave his account to researchers Alistair Boyd and David Martin with the particular care of someone who has carried something for a long time and has decided, finally, to set it down. Boyd and Martin had been investigating the history of the photograph for some years. They had found inconsistencies, followed paper trails, spoken to people connected to the principal figures. What Sperling gave them was not, in the end, surprising in its outline. Many investigators had suspected the photograph was not genuine. What made the confession valuable was its specificity, the details it provided, the small, precise account of how a major cultural artifact had been assembled one afternoon near a Scottish loch. The submarine had come from Woolworths. This is the particular detail that carries its own quiet weight. A toy purchased from a high street shop, a commercial model of the kind sold to children, its conning tower removed and replaced with a sculpted form made from plastic wood filler. The filler had been shaped by hand into a neck and small head. Sperling was a sculptor of professional quality, employed in the trade, and the shaping would not have taken long. The model was small. Estimates have placed it at roughly 30 centimeters or so in length, a scale that made it manageable on the loch's surface but created its own photographic logic. Photographed from close range and low to the water, with nothing in the frame to establish scale, it would read as large. The absence of context was the technique. The day the photographs were taken was, by Sperling's account, an ordinary Scottish afternoon in early April. Ian Wetherell, the son of the man most centrally involved in the enterprise, operated the camera. He knelt or crouched near the water. The model was in the shallows, low in the surface, the filler neck rising from it at the angle that would appear most convincing when printed. Multiple frames were taken. The light was adequate. When they were done, Sperling recalled, the model was pushed under and sunk, a practical and permanent disposal of the evidence. The loch received it. Whatever remained of the toy submarine settled into the sediment or drifted to some unretrievable position in the dark water, and the photographs were taken to Robert Wilson, who agreed to front the story and whose name alone would do the work of authentication. The figure behind this arrangement was Marmaduke Wetherell, Ian's father, and understanding Wetherell's position in the story makes the hoax less puzzling and more human. Wetherven had arrived at Loch Ness the year before, in 1933, commissioned by the Daily Mail itself to investigate the reported sightings. He was a film director, a big game hunter by reputation, a man who had built a professional identity around the discovery and pursuit of remarkable things. The commission suited him. He arrived, he searched, and he found what he presented to the newspaper as the footprints of the creature, large, distinctive impressions near the waterline. The Daily Mail published his report. Wetherill appeared to have delivered precisely what he had been sent north to find. The Natural History Museum zoologists, who subsequently examined Wetherell's plaster casts of the footprints, were careful and unhurried in their identification. What the impressions matched, they found, was the distinctive circular outline of a dried hippopotamus foot, the kind sold in taxidermy and novelty shops as umbrella stands, a Victorian and Edwardian domestic curiosity. The identification was quiet and certain. Wetherell had not found the tracks of an unknown creature near a Scottish loch. He had pressed a hippopotamus foot ornament into the shoreline mud and presented the result as discovery. The newspaper that had sent him reported the exposure. The humiliation was public and complete. Sperling's later account, corroborated by Boyd and Martin's research, placed the surgeon's photo at least partly within the context of this humiliation. The hoax was not only a fabrication, it was a form of reply. Wetherell had been made to look foolish in the pages of the very newspaper that had employed him, and the photograph, attributed to a credible third party rather than to Wetherell directly, allowed the story to continue in a form that his name could no longer reliably carry. Wilson's professional standing did what Wetherell's had been destroyed doing. The photograph was, among other things, an act of substitution, one name for another, one kind of authority traded in for a more stable kind. Boyd and Martin published their full account of the hoax and Sperling's confession in 1999 in a book that laid out the chain of participants, the construction of the model, the sequence of events, and the motivations that had driven them. The account was detailed, sourced, cross-referenced. Sperling had died by then, at 90 years of age, but the record of his testimony remained. The question of the surgeon's photo was, for the purposes of serious investigation, settled. The image had been made by identifiable people on an identifiable afternoon using identifiable materials for reasons that could be traced and understood. The photographic record of what the Loch Ness monster looks like was a toy submarine and a handful of sculpted filler photographed from inches above the water's surface, with all the ordinary light of an April afternoon falling on it. There is something worth dwelling on in what the photograph actually asked of its viewers. It asked them to accept, on the basis of a single image, that a large unknown animal was surfacing in a Scottish loch, and it asked this in a period before the techniques of photographic analysis were widely understood outside specialist circles, before the culture had developed any particular fluency in reading images for signs of manipulation. The newsprint reproduction reduced whatever fine detail the original negative might have held. The scale was unreadable. The water surface around the object gave away nothing. Wilson's name provided the interpretive frame within which most readers encountered the image. They were not looking at a photograph and asking whether it was genuine. They were looking at evidence provided by a doctor and finding that it looked like what they had been told it showed. This is not a criticism of those readers. It describes, with some precision, how images work in relation to authority. The same logic that made the surgeon's photo convincing in 1934 continues to operate in image culture in forms that have simply become more sophisticated. A compelling image attached to a credible source does particular work on a viewer's interpretive instincts. The content of the image becomes, in a sense, secondary. What is read first is the frame, the attribution, the source from which the image arrives. Wilson was a London gynecologist. Gynecologists are not in the habit of fabricating monster photographs. The image must therefore be what it appears to be. This was the logic, and it was not unreasonable. It was simply wrong. The researchers studying public belief in cryptid creatures, those unverified animals that persist in cultural circulation without scientific confirmation, have returned to the surgeon's photo repeatedly as a case study in how a single image can establish the visual template for something that does not otherwise have one. Before 1934, accounts of a Loch Ness creature were verbal, descriptions given by witnesses, narratives recorded in newspapers, words applied to something seen briefly and from a distance. After 1934, there was a shape, a specific silhouette, a long neck, a small head, a rounded body, barely visible at the water line. This shape became the thing. It provided an outline that subsequent sightings could be measured against, that artistic depictions could reproduce, that cultural products, films, illustrations, souvenir merchandise could standardize and circulate. The creature that emerged from the surgeon's photo was not the creature that witnesses had been describing, whose accounts varied considerably and shared no consistent morphology. It was the creature that the photograph showed, which was the creature that Sperling had shaped from filler by hand. What is curious and genuinely worth sitting with is the way the photograph's confession did not do what confessions are generally expected to do. A deathbed statement from the last surviving participant in the construction of a major hoax would, in most circumstances, be expected to close the case. Sperling's account was detailed, consistent, and supported by Boyd and Martin's independent research. The newspaper that had originally published the photograph had been the very publication that exposed Wetherell's earlier fraud. The participants were identifiable. The materials were specific. The Woolworth submarine, the plastic wood filler, the April afternoon, the model sinking into the loch. All of this was documented. The case was, in the ordinary sense of that word, closed. The photograph, however, continued to circulate, not as a document under revision, not as a historical artifact being re-examined. It continued to circulate as the Loch Ness monster in the specific form of the silhouette that the image had established 60 years before, reproduced without qualification on the kind of merchandise that lines the shelves of tourist shops near Drumnadrochit, the village, on the loch's western shore, that has organized a portion of its economy around the creature's continued cultural presence. The long neck, the small head, the suggestion of a hump at the waterline, the shape that Sperling's hands made from filler in 1934, printed on ceramic mugs, pressed into the faces of plush toys, cut from fabric and sewn into keychains, silk screened onto the front of tea towels, in the distinctive green of something associated with Scotland and water and mild mystery. This is not something that can be attributed to ignorance of the confession. In the decades since 1994, the facts of the Sperling account have circulated widely and are available to anyone who looks. The merchandise is not produced by people who believe the image is genuine evidence of a biological creature. It is produced and purchased within a relationship to the image that is not primarily evidentiary, that does not ask the image to prove anything, that asks it only to continue being the shape it has always been. The Loch Ness Monster, in the form that appears on tea towels and postcards, is not a hypothesis about what lives in a Scottish loch. It is a shape in the culture that has outgrown the question of its own origins. Alastair Boyd, one of the two researchers who received and published Sperling's confession, had himself been a genuine believer in the creature's existence before his research led him to the evidence of the hoax. He had spent years investigating sightings and reports, approaching the subject with what he described as serious intent, operating from the position that something real and unidentified might be present in the loch's deep water. The process of following the evidence of the surgeon's photo to its actual source did not, by his own account, produce satisfaction in the way that solving a puzzle is supposed to produce satisfaction. The photograph was the thing the movement had organized itself around, and its exposure as a fabrication removed something from the investigation center that could not simply be replaced. This is the human dimension of the case that is easy to pass over too quickly. The people who had built years of serious inquiry around the surgeon's photo were not naive. Many of them were methodical, careful, knowledgeable about the loch and its conditions, genuinely attentive to the quality of the evidence they examined. Their investment was not in being fooled, but in the possibility of a real discovery, the chance that a large unknown animal might be documented in a body of water in Scotland, that something outside the established biological record might turn out to be present and real. The photograph had given that possibility a face. When the face turned out to be a sculpted form on a toy submarine, the possibility did not necessarily disappear, but its central visual document was gone, and everything that had been built around it needed to be rebuilt without it. There is a version of the surgeon's photo story that emphasizes the deception, the Wetherell connection, the motivation of revenge against the newspaper, the professional man who lent his name to a fabrication. This version is not wrong, but it is only one angle on what happened. A different angle is the photograph as a demonstration of how the culture of the 1930s was structured to receive exactly this kind of image, a period in which the British press was intensely competitive, in which natural history discovery retained a significant public prestige, in which the idea that unexplored territories might still yield genuinely unknown creatures was held by educated people without embarrassment. The Loch Ness Monster, as a cultural event, belonged to its moment. It arrived when it could be believed, and was believed by the kind of people who believe things carefully. The photograph did not create credulous people. It encountered prepared ones. The Daily Mail's role in this history has a particular texture. The newspaper had commissioned Wetherell, had published his fraudulent footprint report, had been embarrassed by the Natural History Museum's exposure of that fraud, and had then published the surgeon's photo. without knowing, as far as Boyd and Martin's research established, that it was constructed in part as retaliation for that earlier embarrassment. The newspaper that was deceived was in some sense the same newspaper that had created the conditions for the deception by setting the original story in motion. Wetherill's humiliation flowed from the Daily Mail's commission. The surgeon's photo flowed from Wetherill's humiliation. The chain was tighter than it appeared on the surface of the events. Boyd and Martin spent considerable time establishing the precise participants and the precise sequence. Beyond Marmaduke Wetherill and his son Ian, and beyond Sperling as the model's constructor, the question of Wilson's knowledge and motivation was more complex. Was Wilson an innocent front, a man who had simply allowed his name to be used, perhaps as a favor, without knowing the full context of what he was lending his reputation to? Or did he understand from the beginning that the photograph was fabricated and choose, for reasons of his own, to participate in the deception? Sperling's account offered some material on this point, but stopped short of full clarity, and Wilson himself never spoke publicly about the photograph in any way that could be used to resolve it. He maintained throughout his life a consistent refusal to say much about the matter at all, which was its own kind of statement about the kind of man he was, or the kind of situation he believed he was in. This is the quality of the case that makes it durable as an object of attention, not the deception itself, which was, once Sperling spoke, relatively straightforward in its mechanics, but the human geometry around it. The vanity and the humiliation and the revenge and the professional calculation and the name that was lent or was traded or was used without full knowledge. And behind all of this, the question of the loch itself, which had nothing to do with any of them, sitting in the Highland Hills in its tectonic fracture, dark and cold and genuinely deep, quite indifferent to what a photograph had made of its name. Boyd and Martin's 1999 book ran to hundreds of pages. It is a careful document, the kind of work that takes years to produce and addresses its subject without the desire to simplify it into something more satisfying than it actually is. The surgeon's photo, as they present it, is not a simple story of cynical fraud. It is a story about the specific kind of moment in which a fabrication can achieve cultural permanence, about the way a public need for evidence shapes the evidence that gets produced, and about the particular chemistry between a newspaper with something to prove and a man with a grievance that needed to find a form. The photograph was, in their account, the product of a specific set of pressures acting on specific people at a specific time, and its 60-year career as the visual record of the Loch Ness monster was the product of those same pressures, operating at the scale of a culture rather than a lochside afternoon. The small dark shape on the newsprint page, the neck, the head, the suggestion of depth behind the surface of the image, continued to function as the Loch Ness monster, in part because no subsequent image ever replaced it. The decades of investigation, the sonar surveys, the photographic expeditions, the underwater cameras, the systematic surface watching programs run by organized groups with equipment and protocols, none of it produced an image that was both convincing and unimpeachable. The surgeon's photo remained the picture even as the picture's falseness was established, because the alternative was no picture at all, and a shape in the culture requires something visual to anchor it. The silhouette that Sperling made from filler held its place in the cultural imagination, not because people continued to believe it was real, but because there was nothing to put in its place. Near Drumnadrochit, on the western shore of Loch Ness, the tourist shops maintain their inventories with the matter-of-fact consistency of businesses that know their market well. The ceramic mugs are stacked, the tea towels are folded, the plush toys sit in bins near the door. On each of them, the long neck rises from the dark water, the small head turns slightly. The hump suggests a body below the surface. The silhouette is 60 and more years old. The man who shaped the neck and head with his hands died in 1994, at 90 years of age, having described the afternoon of its making in careful detail to the researchers who had come to hear him. The model that held the shape has long since dissolved into whatever the loch does, with things left in it: the peat dark water, the cold, the sediment floor where things settle and do not return. The shape, however, persists. It moves through the world on cloth and ceramic and paper, reproduced in the millions, recognizable to anyone who has ever heard the name associated with a Scottish loch, carrying within its outlines no particular claim about what lives in the water, only the continued fact of its own presence in the visual world. The small dark figure still rising from the dark water, still the same shape it was on a particular April morning when it was photographed from inches away and set in motion. The question of what it is, having long since been answered, the question of what it means, still drifting quietly, open, without a bottom. The photograph itself, in its original printed form, the April 21st, 1934 Daily Mail page, the newsprint, the caption, the byline, now lives in archive collections, in media history libraries, in the holdings of institutions that preserve what newspapers once printed. The image has aged into the quality of historical documents. It is primarily a record of a moment in the culture now, the moment in which a public saw what it had been prepared to see, held in the specific gravity of a professional man's name, a gynecologist who kept his silence, a film director who wanted satisfaction, a sculptor who shaped something small and dark and waited for the water to receive it. The afternoon closing over all of them, the loch going on without comment, and the shape beginning its long journey through everything that would come after. What Boyd and Martin established, and what Sperling's testimony secured, is that the surgeon's photo is a closed case in its factual dimensions and an open one in every other sense, open to the extent that images do not close when their origins are explained, open in the way that a thing released into the culture belongs to the culture rather than to the circumstances of its making, open the way the silhouette on the tea towel is open, which is to say, available, unresolved in its meaning, continuing. The question the photograph carries is no longer the biological one, no longer whether a large unidentified creature surfaces in a Scottish loch and has been captured on film. The question it carries now is the one that long outlasts any specific deception, the question of what an image is once it has been separated from the truth of its making, the question of what it becomes when it has moved far enough from its origin that its origin no longer determines what it does in the world. The small figure in the water, the neck and the head, and the suggestion of something below the surface, printed on newsprint in April 1934 and still circulating in its silhouette form on a morning in any year that comes after, unchanged, unresolved, making no claims about the dark cold water of a Scottish loch, asking nothing of the person who sees it, simply continuing to be the shape it is, the shape that a sculptor's hands made in the particular light of an afternoon that has long since been absorbed into the past, the shape that keeps its own counsel now, still dark, still rising, still the same. Around 690 AD, a monk named Adomnon sat in a scriptorium on the island of Iona and wrote, in careful Latin, about a creature in the water. The manuscript he produced, the Vita Columbae, a life of the Irish missionary Columba, was a work of hagiography, a document composed according to precise conventions. its purpose the establishment of sainthood rather than the recording of natural history. Adamnan had not witnessed the events he described. He wrote approximately a century after Columba's death, drawing on oral tradition, on the institutional memory of the monastery Columba had founded, on the accumulated stories a community preserves about its founding figure. The document survived. It was copied and recopied across the medieval centuries, passing from island to island and monastery to monastery, carrying within its careful Latin phrases an account of a swimmer, a river, and a creature that rushed upward from the water before being turned back by a raised hand. The River Ness in the 6th century was a different kind of place than it is now. The roads along its banks were not yet roads. The settlements were small and scattered. The missionaries who moved through the highland landscape did so on foot, or by coracle, or on borrowed horses, and they moved through a world in which the water was understood to be inhabited, not figuratively, not merely as a figure of speech, but in the serious, detailed, specific sense that a culture maintains when its relationship to a landscape is intimate, and its explanations for that landscape are theological. Adnan's account of the River Ness encounter follows closely the formal pattern of a hagiographic miracle. A threat appears, the saint acts, the threat is repelled, the onlookers bear witness. This pattern repeats throughout the Vita Columbae in encounters with storms, with hostile kings, with illness, and with dark forces of various kinds. Scholars who have studied the manuscript note this consistency with care, observing that the account functions as a demonstration of Columba's spiritual authority rather than as a field report on the local fauna. The River Ness appears in the narrative as a setting in which that authority could be displayed. What was in the river is secondary to what the encounter proved about the man standing on the bank. The river flows north from Loch Ness into the Moray Firth, approximately 30 kilometers of water connecting the deep inland loch to the sea. The account Adamnan recorded is specifically set in the river, not in the loch itself, a distinction that tends to be lost when the story is retold in the context of the monster mythology that came much later. The swimmer in the water, the creature rising, the monk commanding it away, these happen at the river's edge, in shallow enough water that observers on the bank could see clearly what was occurring. This is not the deep interior of a dark loch. It is a river crossing, a practical and ordinary event in missionary travel, transformed by Adamnan's account into something that would be copied and read and discussed for the next 14 centuries. The creature in the river was given no name in the manuscript. It was described in terms that matched the hagiographic vocabulary available to Adamnan. A beast, an aquatic presence, something that moved with intent toward the swimmer before being stopped. What name the local people along the riverbank might have given it, in the language they spoke rather than the Latin Adamnan wrote, is not recorded anywhere that has survived. The indigenous framework for understanding unusual encounters with water in the Scottish Highlands was not the framework of natural history. It was the framework of a landscape understood to be alive with presences, some benign, some dangerous, some deeply ambivalent, whose behavior followed patterns that the oral tradition documented and transmitted across generations. The Kelpie, or Each Uisge in Gaelic, was one of those presences. The name translates roughly as water horse, and the creature it named occupied a specific and consistent role in the tradition. It was a shapeshifter, capable of appearing as a beautiful horse on the loch side, luring a rider onto its back, and then plunging into the water to drown them. Variations on the account placed it in rivers as well as lochs, gave it different secondary abilities depending on the region, and associated it with specific named bodies of water. Folklorists including Ronald Black have documented accounts of each Uiska tradition from the Loch Ness area specifically, accounts in which unusual encounters near the water were understood through this framework rather than as evidence of an unknown biological animal. The creature in these accounts was supernatural. It had intentions. It could be appealed to or avoided, or in some versions outwitted, in ways that a large fish or an unknown reptile could not be. The tradition was not natural history. It was something older and more comprehensive, a way of understanding why the water was dangerous and what kind of attention it required. Loch Ness in the Gaelic oral tradition was not an empty or neutral body of water. It was a named place in a landscape of named places, each name carrying information about what had happened there, or what was believed to inhabit that stretch of shore, or what kind of caution a traveler on the water needed to exercise. Elizabeth Sutherland, researching the oral geography of the area, documented specific locations around the loch whose Gaelic names encoded old knowledge, points on the shore identified as places of danger, stretches of water associated with unusual events, the kind of intimate local naming that reflects generations of careful attention to a particular piece of ground. The names are still there. Some of them appear on modern maps in anglicized form, carrying their meaning in a language that most people who read them no longer speak. Others survive only in the scholarly records of those who documented them before they passed out of common use. The loch they describe is unchanged. The same water moves in the same basin, under the same highland sky, and the names given to its shoreline continue to hold what was once known or believed about each of those places, whether or not anyone reading them now can hear what they are saying. There is a particular quality to a place that has been named and renamed again across centuries, each layer of naming depositing its understanding on top of the one before, so that the same stretch of water holds simultaneously the Gaelic understanding of the each Uska, the monastic Latin of Adamnon's miracle account, and whatever additional meanings the centuries between have added. The loch is still. It does not record these layers itself. The water is the same water regardless of what has been said about it. What changes is the human attention brought to it, the frameworks through which the surface and the depths are interpreted, the readiness of any given observer to understand what they see on the water as belonging to one category or another. The each Uska tradition prepared its inheritors to expect unusual things at the water's edge and to interpret them within a specific framework. The hagiographic tradition prepared its readers to understand dangerous presences in water as things that could be repelled by saintly authority. Neither framework required a discrete biological animal in the loch to sustain itself. Both frameworks generated accounts that have been read in the light of the 20th century as something they were never intended to be. The spring of 1933 brought a different kind of attention to the loch. The A82 road along the western shore had recently been completed, and for the first time in the loch's history, a substantial number of people could travel quickly along its length by car, scanning the water as they drove. The road opened the loch side to a class of observer that had not previously existed: the passing motorist, the visitor, the tourist, whose relationship to the landscape was primarily visual rather than intimate, who arrived without the accumulated local knowledge that tells a person which shapes on the water are ordinary and which are not, and who was therefore more likely to find the surface surprising. John Mackay was not a passing motorist. He was the proprietor of the Drumnadrochit Hotel, a man whose daily life was organized around the loch and its vicinity, someone who had lived with the water as a familiar background rather than as a spectacle. On an afternoon in late April 1933, Mackay and his wife Aldi were driving along the northern shore road when both of them saw something on the surface of the loch that neither could immediately explain: a violent disturbance, a churning of the water, a movement that did not match anything they had a ready category for. They drove on. They mentioned it to people they knew. Word of what they had described reached Alex Campbell. Alex Campbell held several roles in the community around Loch Ness. He was a water bailiff, responsible for the management and monitoring of the loch's fish populations. He was also a part-time journalist, contributing occasional reports to the Inverness Courier, the regional newspaper that served the highland area north of the loch. When the Mackay account came to his attention, Campbell recognized it as something worth putting into print. He wrote it up for the Courier. The account appeared on May 2nd, 1933, describing what the Mackays had seen in terms that were specific enough to be vivid and general enough to resist easy dismissal. What Campbell chose to call what they had seen was a monster, not a large fish, not an unusual wave formation, not a disturbance of uncertain origin, a monster. He wrote the word down. The editor printed it. The paper circulated through the Highlands and within a short period, beyond the Highlands into the wider British press. A single word, chosen by a part-time journalist with a good instinct for what would hold a reader's attention, attached itself to a place that had been carrying stories about the water for centuries, and became the frame through which everything that followed would be understood. The Inverness Courier piece was not the first report of something unusual in the loch. Accounts of unusual sightings along the loch had circulated locally for years without attracting sustained wider attention. What Campbell's report provided was not new information, so much as a new category, a name that organized the various accounts into a single phenomenon and made that phenomenon available for wider discussion. The word monster implied size. It implied strangeness. It implied that whatever was in the loch was not merely a large but ordinary animal that could be explained by a competent naturalist. It created, in the minds of readers who had never seen the loch and had no prior relationship to its landscape, a template for what kind of thing the loch contained. And it gave future observers, the people who would drive along the new A82 road and scan the water's surface, a framework within which to interpret whatever they might see. If what a person sees is organized by what they expect to see, then the publication of the Courier piece created conditions in which new sightings became more likely, not because the loch had changed, but because the attention brought to it had cooled. The surface of the water was the same surface. The expectations of the people watching it were not. The year 1933 produced a quantity of reported sightings that had no precedent in the documented history of the loch. Investigator Ronald Binns, examining the historical record carefully, identified the completion of the A82 road and the publication of the Courier account as structural contributors to this increase, practical factors that placed more observers at the water's edge and gave those observers a framework for what they might be looking at. The increased traffic along the loch side was measurable. The effect of the Courier framing on subsequent interpretation was harder to quantify, but no less real. People who had grown up near the loch and had seen unusual things on the water over the years had not previously had a reason to report those observations to a newspaper. The Courier piece changed that. Reports began arriving from people who had seen something months or years earlier and had not known what to call it. The name provided by Campbell's report gave these experiences a public category, and the public category generated more public reports, and the reports generated more press coverage, and the press coverage generated more observers driving along the new road with their attention focused on the surface of the water. The loch had been there for 10,000 years. The network of attention that formed around it in the spring and summer of 1933 had not existed 12 months before. The Ichiui's tradition and the Kelpie stories that circulated through the highlands were not imported from elsewhere. They emerged from the specific character of the landscape, from the particular quality of a deep, dark loch in a highland valley, from the genuine dangers that bodies of water present to people who live near them, from the human instinct to understand danger as having a face and a will rather than as being merely mechanical. These traditions did not require the loch to contain a discrete biological animal. They required the loch to be the kind of place that demanded respect and wariness, and the loch was that place, whether or not anything unusual lived in it. The water was deep, it was cold, it was dark below a short distance from the surface. People drowned in it. Animals drowned in it. The mist that settled over it on autumn mornings could make it look like a different body of water entirely. The oral tradition that grew up around it reflected all of this, the genuine strangeness of the place, held in a framework that made the strangeness navigable rather than simply alarming. The Ichiwaj was a danger that could be understood and therefore in some sense managed. An unknown biological creature of uncertain size and habit offered no such comfort. What Adamnan wrote in his manuscript in 690 AD was not, by any scholarly reading, a field account of an unknown species. The conventions of hagiography that shaped his writing required miraculous encounters with threatening forces. The river Ness provided a setting. The creature that appeared in the water provided the threat. Columba's authority provided the resolution. The account told the reader something specific and important about Columba, about the nature and extent of his spiritual power, about his ability to protect those traveling with him, about the seriousness with which the new Christian faith could engage with the dangerous presences that the older understanding of the landscape had always acknowledged. That older understanding was not dismissed by Adamnan's account. It was absorbed into it. The dangerous presence in the water was real enough, in the framework Adamnan was working within, that it needed to be repelled rather than simply denied. Columba did not tell the swimmer that there was nothing in the water. He turned the creature back. The account worked for its intended audience precisely because it did not deny the water's danger. It demonstrated that the danger could be faced. The long tradition of oral geography, documented by Elizabeth Sutherland, represents something different from both the hagiographic miracle account and the natural history investigation. It represents the accumulated, embodied knowledge of people who lived with a specific piece of water across many generations, who fished it, crossed it, drew water from it, watched their children near it, and over time built up an understanding of its particular character that expressed itself in names. The Gaelic language is precise about landscape in ways that English is not. A named point on a loch shore in Gaelic oral tradition carries within the name information about what kind of ground it is, what kind of weather typically arrives from that direction, what the water does there in certain conditions, and often what history, human or otherwise, is associated with that place. The names Sutherland, documented around Loch Ness, were not decoration. They were knowledge, organized in a form that could be transmitted without writing, carried in memory and in ordinary conversation, updated by each generation as the landscape provided new information and the tradition decided whether to absorb it. These named places still exist. They are not abstract. They are specific points on a shoreline that can be visited, specific stretches of water that can be stood beside and looked at. The names some of them carry in their anglicized form on modern maps are pale echoes of what the Gaelic names said. But even in anglicized form, they are present on the ground, attached to the actual landscape rather than to any particular theory, about what the landscape might contain. A visitor to the loch today who knows the Gaelic names and their meanings is in contact with something that has been present in that place for a very long time, an understanding of the water that precedes the Inverness Courier by centuries, that precedes the surgeon's photo by more than a millennium, that was already old when Adamnan sat in his scriptorium and composed the account of Columba at the river crossing. The tradition is not evidence of a creature. It is evidence of a relationship between a people and a body of water, maintained across generations in the form of careful, specific attention on an autumn evening on the northern shore of Loch Ness, with the light going out of the sky and the hills across the water becoming dark shapes rather than distinct features. The surface of the loch has a quality that is difficult to describe in terms that are not borrowed from the tradition that grew up around it. The water is very dark. In certain lights it appears almost black. The far shore, which is not far, the loch is only about 1.5 kilometers wide at most points, becomes invisible in low light more quickly than distance would seem to warrant, because the darkness of the water and the darkness of the hills and the darkness of the sky above them all merge into a single absence of light that the eye cannot differentiate. A person standing at the water's edge in this light, in a condition of genuine quiet, in a landscape that is genuinely large and genuinely indifferent, is in a situation that the Ichiwiska tradition understood very well. The tradition did not manufacture the darkness. It did not manufacture the cold, or the depth, or the silence. It responded to what was actually there. What was there was real enough to generate stories, and the stories were specific enough to survive. And the survival of the stories across so many generations suggests that the landscape itself, regardless of what it may or may not contain, consistently produced the kind of experience that required explanation. The May 1933 account in the Inverness Courier was not the end of a process, but the beginning of one. Alex Campbell, writing at his desk in Inverness, composing the Mackay account, and reaching for the word that would best convey what they had described, was not consciously setting anything in motion. He was doing what journalists do, finding the phrase that makes a story vivid and transmissible, choosing the word that will make the reader want to read the next sentence. That the word he chose was the same word that would appear in newspaper headlines and scientific papers and souvenir shop merchandise for the rest of the century was not something he could have known. The word fit the account fit the place. The place had been carrying the weight of older stories about the water for centuries before Campbell's piece was filed, and it absorbed the new story as it had absorbed the others, holding it against the landscape, letting the landscape give it weight, continuing unchanged beside it, while the story traveled outward into the world and began to acquire a life of its own. The swimmers in Adamnan's account, the travelers warned away from the lochside in the Ichiwiska stories, the Mackeys driving along the new road on an April afternoon, all of them were in contact with the same body of water, the same deep cold basin, the same dark surface that reflects the hills in perfect stillness and drops away beneath to depths that have been measured but not fully explored. What they saw, or believed they saw, or reported having seen, belongs to several different frameworks simultaneously: the hagiographic framework, the supernatural indigenous framework, the newspaper report framework. Each framework generated its own account of what the water contained and what kind of attention it required. None of them required the others to be wrong in order to do their work. The loch held all of them, as it holds everything: the Gaelic names on its shoreline, the Latin of Adamnan's manuscript, the word that Campbell wrote in the spring of 1933, without being changed by any of them. There is a specific named point on the shore of Loch Ness, documented in Elizabeth Sutherland's research into the Gaelic oral tradition of the area, where the name that was given to that place encodes something about what once happened there or was once believed to be present there. The name is attached to a real place. The place is still there. The water beside it is the same water that was there when the name was first given, moving in the same basin, cold at depth, dark from a short distance below the surface, covering a floor of fine sediment that has been accumulating since the ice retreated from the Great Glen 10,000 years ago. The name carries its meaning, whether or not anyone reading it now can hear it. The story that generated the name may have been about a supernatural presence. It may have been about a drowning. It may have been about an encounter with something in the water that the people who witnessed it could not identify and therefore named carefully so that the next person to come to that place on the shore would know what kind of attention it required. The loch moves beside it quietly. The name remains. The question of what was seen there, and when, and by whom, is very old, and it remains open, and the water continues past it unchanged. On a research vessel on Loch Ness in the summer of 1968, a paper trace rolled slowly from a sonar machine mounted in the hull. The stylus moved in its steady arc across the paper, and then, at depth, marks appeared, dark impressions on the pale roll, clustered and distinct, showing contacts moving through the water below the boat at speeds that the operator noted, measured, and eventually published in a peer-reviewed scientific journal. The surface of the loch above them was undisturbed. Whatever had produced those marks was somewhere in the dark water beneath the hull, moving at a pace the instruments could quantify, but the eye could not follow. D. With the soartfall bitch the aftan ply called plop. Dit alles just for de peoples, from one clampilig roaded at peoply to her own 30s. Gordon Tucker was a professor of electronic engineering at the University of Birmingham. He had not come to Loch Ness as a believer in any particular theory. He had come with calibrated equipment and a scientist's interest in what the equipment would record. His sonar system, deployed from the loch's surface in 1968, produced contacts that moved at depths in the basin below, contacts he documented with the specific care of someone who understood exactly what his instruments were measuring and exactly what they were not. In his published findings in New Scientist, Tucker described the contacts as showing characteristics one would expect from a large animate object. He did not claim more than that. The paper trace recorded what it recorded. The characterization he offered was precise, bounded, and open. A scientist describing what his instruments suggested without asking them to suggest anything beyond their range. The phrasing is worth attending to carefully. Tucker did not write that the contacts were a large animate object. He wrote that they showed characteristics one would expect from one. The distinction is not incidental. It is the exact distance between what the instruments established and what they could not. Sonar records movement, depth, and the acoustic reflectivity of whatever produces a return. It does not identify species or confirm biology. What Tucker's equipment recorded in 1968 was a set of measurements that were consistent with certain kinds of large moving things. Measurements that, after analysis, he considered worth publishing in a forum that subjected scientific findings to review. The paper appeared. The contacts remained unexplained. The loch continued as it always had, holding whatever it held in water too dark and too cold for any straightforward inspection. That publication placed Tucker's findings in a different category from most of what Loch Ness had generated up to that point. A peer-reviewed journal is not a newspaper. The discipline required to publish there, the specificity, the care with claims, The acknowledgement of what the evidence does and does not support is its own kind of documentation. Tucker's contacts had been measured by calibrated equipment, analyzed by someone who understood the limitations of that equipment, and submitted to the scrutiny that scientific publishing requires. What survived that process was modest but real. Multiple large contacts, movement at depth, speeds around 17 kilometers per hour, characteristics consistent with large animate objects. The question of what produced them was not answered. It simply passed into the record, undisturbed. Nearly 20 years after Tucker's paper appeared, the largest coordinated sonar search the Loch had ever seen was organized on its surface. In October of 1987, a flotilla of 24 motor cruisers moved into position across the full width of Loch Ness. Each boat carried a Lorentz echo sounder sonar unit. The boats were arranged in a line abreast formation, positioned close enough together that their sonar beams covered the loch from shore to shore without significant gaps. The formation moved forward together, sweeping from one end of the loch to the other, the sonar units pinging downward through the water column as the Highland autumn light flattened the surface to pewter around them. On the shore, journalists watched. The operation had been given a name, Operation Deep Scan, and the name described exactly what it attempted. The organizers understood that no single survey vessel could meaningfully search a loch of Loch Ness's dimensions. The basin is approximately 37 kilometers long and drops in places to depths exceeding 200 meters. A single boat, moving its sonar beam back and forth across the loch's length, would take considerable time and would leave significant gaps between passes. 24 boats in formation could approach the problem differently, could cover the full width of the loch in a single pass, moving the coverage laterally as the formation advanced, producing a more systematic map of what the water contained. The concept was sound. The execution, on those October days in 1987, proceeded as planned. The flotilla moved. The sonar units recorded. The paper traces accumulated as the formation crossed the loch's full length. 3 contacts appeared in the records from the deep central basin. They were larger than any fish species known to inhabit Loch Ness. The Loch Ness units had recorded returns from something in the deep water that did not match the loch's documented inhabitants. The contacts were noted, logged, and subsequently examined. What followed was the kind of careful qualification that large anomalous data points tend to attract. Investigators considered whether the contacts might represent debris on the loch floor that the sonar had returned from unexpectedly, or whether the contacts were artifacts of the sonar equipment itself, patterns produced by the acoustic environment of the deep basin rather than by any discrete physical object. The equipment had recorded something. Whether that something was biological, structural, or instrumental in origin was not established. The contacts were included in the expedition's findings. No definitive identification was made. The particular difficulty of Operation Deep Scan's contacts was that they lay at the intersection of what sonar can and cannot establish. Echo sounder technology records acoustic returns, the time it takes for a sound pulse to reflect back from an object, and the strength and character of that reflection. From these measurements, analysts can estimate size and position, and in some cases movement. What the technology cannot do is tell the analyst what kind of object produced the return. A large fish, a submerged log, a debris field on the sediment floor, a thermal layer that reflects sound unexpectedly. Each of these can produce anomalous returns under the right conditions, and distinguishing among them from the acoustic record alone requires assumptions the record itself cannot validate. The 3 contacts from the deep central basin remained in the data. They remained unresolved. The flotilla returned to shore, the sonar units were recovered, and the loch resumed its ordinary surface stillness above whatever it was that the instruments had measured. The Loch Ness Investigation Bureau had approached the loch's questions from a different direction entirely. Established in 1962 by David James, a member of Parliament, and Peter Scott, the naturalist and artist, the Bureau operated on the straightforward logic that if something surfaced in Loch Ness with any regularity, sufficient observers with sufficient cameras positioned at strategic points along the loch's shores would eventually capture it on film. The Bureau was not a casual enterprise. It ran for a decade, stationing camera-equipped volunteers at lochside observation points each summer, volunteers who came with 35mm cameras on tripods, with binoculars, with observation logs, and with a systematic commitment to watching the water carefully rather than glancing at it in passing. The observation logs from those summer seasons are their own kind of record. Volunteers recorded the date and time, the weather and light conditions, the state of the surface, and whatever they observed in careful handwriting. The logs document hours of watching, long stretches of uninterrupted surface stillness, periods of surface movement that resolved into weather or wakes, occasional events that remained less easily categorized. The Bureau accumulated what it set out to accumulate, a substantial archive of observation records and film material gathered over 10 years of systematic effort. What it did not accumulate in a decade of sustained watching was definitive evidence of any unidentified creature on or below the surface of the loch. The Bureau disbanded in 1972. The archive passed into storage. The loch continued unchanged. A volunteer stationed at a Bureau observation point on a summer morning in the late 1960s would have occupied a specific kind of attention, the patient, open, unhurried attention of someone watching a large body of water for hours at a time, with nothing to do but watch. The folding chair, the camera on its tripod, aimed at a particular stretch of the surface, binoculars raised and raised again as something drew the eye and then resolved into wake or wind or a bird landing and lifting off. The observation log open on the clipboard beside the chair, the entries accumulating through the morning, time, conditions, surface state, any event of note, and the careful notation of what the event resolved into once observed carefully. The Bureau's work was this: steady, unspectacular, serious watching. The decade of records it produced documents not what was found, but what was looked for, and in the specific terms the Bureau required, not found. The question of what the loch might contain at depth was approached from a genuinely different angle in 2018, when Professor Neil Gemmell of the University of Otago led an international research team to Loch Ness with an entirely different kind of instrument. Environmental DNA analysis does not use sonar or cameras or the patient observation of a volunteer with binoculars. It works from the fact that every living organism sheds genetic material into the environment around it: skin cells, scales, mucus, waste, and that this genetic material persists in water for long enough to be collected, amplified, and identified in a laboratory. A water sample drawn from a lake contains, in principle, traces from every species that has recently been present in that water. The sequencing equipment reads those traces. The results describe who has been there. Gemmell's team drew water samples from multiple locations and multiple depths throughout the loch. Each sample was contained in a sealed bottle, labeled with its position and depth, cold and dark, carrying within it the accumulated genetic signatures of whatever had been present in that portion of the water column. The bottles were delivered to the laboratory, The sequencing proceeded. When the results came back, they identified traces from over 3,000 species in the waters of Loch Ness, a comprehensive picture of the loch's biological community, from microscopic organisms in the surface layer to whatever inhabited the deeper sections of the basin. The genetic portrait was, in its breadth, remarkable. In the specifics that had drawn public attention to the project, it was precise and bounded. No genetic evidence of reptiles was found, no genetic evidence of sharks, no DNA consistent with plesiosaur-related organisms or with any large marine creature that might have entered through a theoretical connection to the sea. The categories of animal most commonly proposed as candidates for the sightings that had accumulated over the decades were simply not present in the genetic record the water contained. The sequencing equipment had looked for them and not found them. That is a finding. It is not absolute. Environmental DNA surveys have their own limitations, including the possibility that very rare individuals might not shed detectable material during the period the samples were drawn. But it is specific. It is measurable. It occupies a different register from absence of evidence more generally. What the eDNA survey did find, and what Gemmell noted publicly in careful terms when the results were announced, was an unusually high concentration of eel DNA relative to other freshwater bodies of comparable type. The loch held eels that had been known, but the proportion of eel genetic material in the samples was higher than baseline comparisons with other Scottish lochs would have predicted. Gemmell was precise about what this finding did and did not establish. He stated that he could not confirm the presence of giant eels in Loch Ness. He stated that the eel DNA concentration was consistent with an eel population that included very large individuals. The distinction matters, and Gemmell held it carefully. What the eDNA record showed was a quantity of eel genetic material that raised a question the data could not itself answer. A question about whether the concentration reflected a large number of ordinary-sized eels or a smaller number of individuals that had for some reason grown far beyond the expected size range for the species. A sealed sample bottle drawn from 60 meters below the loch's surface holds something worth considering for a moment. The water inside it is cold. The loch's deep water remains at 5 to 6 degrees Celsius year-round, a temperature stable enough to preserve genetic material. The water is dark. To the eye, the sample looks undifferentiated, just water, slightly cloudy with peat particles, no visible content beyond its color. But within it, distributed through the cold column from which it was drawn, are genetic traces from every organism that has been in that section of the loch in the weeks before the sample was collected. The sequencing equipment reads them. The analyst looks at the output and describes the community the water records. That description, for Loch Ness in 2018, was detailed and complete in most respects. In one respect, the question of eel size, it remained open in a way that the data itself acknowledged. Eels present a particular complication when it comes to questions of size. The European eel, Angula angula, migrates from freshwater rivers and lakes to the Sargasso Sea to spawn at the end of its life. This migration is triggered by hormonal changes associated with sexual maturity. An eel that does not reach sexual maturity or whose migratory trigger fails will remain in freshwater and continue growing. The growth is slow, but in a cold, deep loch with sufficient food and over a long enough period, an eel that has remained in freshwater beyond its expected lifespan could reach a size considerably beyond what is standard. How far beyond, whether meters beyond, is a question the biology of the species makes genuinely open. The eDNA data from Gemmell's survey sits alongside that biological fact without resolving it. the high concentration of eel DNA, the documented biology of a fish that continues growing when it stays, the cold, deep, food-bearing water of a loch that has been collecting whatever enters it since the last ice age. These facts coexist in the record without producing a conclusion. That is where the data leaves them. The investigation conducted in September of 2023 returned to the loch with a different instrument configuration and a specific area of interest. The Loch Ness Exploration Group, which had organized a search event that August and September, deployed a high-resolution side-scan sonar system from a research vessel moving across the loch's surface. Side-scan sonar works differently from the echo sounder units used in Operation Deep Scan. Rather than directing a ping straight down from the hull and measuring the return from the floor or from objects directly below, side-scan sonar projects acoustic beams at an angle to either side of the vessel, producing a detailed image of the loch floor and of objects in the water column within the scan's range. The resulting data is more spatially detailed than a simple depth return. It can render the shape of objects rather than simply indicating their presence. During one pass, the system recorded a contact approximately 9 meters below the surface. The contact appeared in the sonar data as a shape that the group's operators noted could not be immediately explained by reference to known debris in that location or by the kind of surface fish behavior the system commonly recorded. The contact was logged. Its position and depth were noted. The recording system captured the image, a specific shape, at a specific depth, at a specific location on the loch, on a specific date in September 2023. The operators indicated the data would be shared publicly and subjected to further technical analysis. The group stated that no definitive identification had been made. The language the group used in describing the contact was careful in the way that such language generally is when the people using it understand what their instruments can and cannot establish. The contact was described as unexplained, not as evidence of a large unidentified creature, not as proof of anything in particular, but as a sonar return that the available context did not immediately account for. That is a precise and honest characterization. Sonar can record the presence of an object and indicate its approximate size and position. It cannot identify what kind of object it has recorded. A contact 9 meters below the surface that does not match known debris and does not behave like surface fish could be a number of things. A large individual fish of a known species, an accumulation of material suspended in the water column, something else entirely. The data file records what the instrument measured. The question of what produced the measurement remains open in exactly the terms the data establishes. There is a quality common to all the instrumental records that Loch Ness has generated over more than half a century of organized investigation. Each of them documents something real, a measurement taken by calibrated equipment, a genetic trace recovered from the water column, a paper contact on a sonar trace, a shape on a scan, and each of them stops at the edge of what the instrument can establish. Tucker's paper trace from 1968 documents contacts moving at depth, at a speed consistent with large animate objects, and stops there. The Operation Deep Scan contacts document 3 returns from the deep central basin that exceed the size of any known loch inhabitant, and stop there. Gemel's eDNA results document an unusually high concentration of eel genetic material and stop there. The 2023 sonar contact documents an unidentified shape at 9 meters depth and stops there. The instruments have been precise. The conclusions they permit have remained consistently bounded by that precision. What accumulates in the record across 50 years in multiple technologies is not evidence of any particular thing. It is a pattern of unexplained measurements distributed across time, across different instrument types, and across different methodological approaches. Tucker used acoustic equipment from a research vessel in the summer. Operation Deep Scan used a coordinated fleet of echo sounders in autumn formation. The Bureau used visual observation and film technology across a full decade of summer seasons. Gemmel used molecular biology from water samples. The 2023 group used high-resolution side-scan sonar from a dedicated research vessel. Each approach produced something: a measurement, an anomaly, a finding that raised a question the instrument could not answer. None of them has produced an identification. The pattern of unexplained things in the record is itself a kind of document. The loch produces this pattern partly because of what it is. The water column below 30 meters is near opaque to conventional cameras and to divers. The peat particles that suspend throughout the water column absorb and scatter artificial light within meters of the source, returning almost nothing from below. Acoustic instruments work in that environment, where optical ones do not. Sound travels through peat-suspended water as well as through any other freshwater column, but acoustic instruments record what they record and identify nothing further. The loch has been measured in considerable depth and from considerable technological angles. What it has not been, in any meaningful sense, is seen. The distinction between measuring a place and seeing into it is real, and at Loch Ness, for all the instruments trained on it over decades, the loch's interior remains largely in the category of the measured rather than the seen. The record from Tucker's 1968 sonar investigation sits now in the archive of published scientific findings from Loch Ness, a paper in a peer-reviewed journal. The contacts described with the specific care of someone who understood both what his equipment measured and what it did not. The paper is old now. The stylus that marked those contacts on the rolling paper has long since ceased to move, but the data described in that publication persists in the record of what instruments have found at Loch Ness, alongside the Operation Deep Scan contacts and the eDNA findings, and the 2023 sonar image, each of them a specific measurement from a specific instrument at a specific time, each of them stopping at the boundary of what the instrument could establish. Gemmel's data file from the 2018 survey is held at the University of Otago. It is a digital archive, a record of the genetic traces recovered from the loch's water column at multiple positions and depths during the survey period, processed through the sequencing pipeline and returned as species identifications and relative concentrations. The file is time-stamped. It is accessible to researchers who want to examine the underlying data rather than the summary findings. Within it, the eel DNA concentration is recorded at the values the sequencing produced, a number at each sampling location expressing the relative abundance of eel genetic material in that portion of the water column. The number is higher than comparable values from other freshwater bodies. The question that number raises about size, about individuals, about what an eel in that cold, deep water might become if it stayed long enough, remains in the file without an answer attached. The side-scan sonar image from September 2023 similarly exists as a data file somewhere, a recording of the contact at 9 meters depth, the shape the instrument returned, the position logged, and the depth noted. The Loch Ness Exploration Group indicated the data would be submitted for further technical analysis. No published identification has emerged from that analysis. The file is open. The contact is unresolved in the specific narrow, instrumental sense, meaning the instrument recorded something, the operators noted it, and what produced it has not been established from the available data. None of these files are exciting, in the sense that excitement usually requires a conclusion. They are measurements. They record specific things about specific conditions in a specific body of water, and they stop at the boundary of what the measurement can establish. That boundary is the same in all of them. The loch continues beyond it, unaffected by any of the instruments trained on its surface and its depths. The water in the deep basin sits at 5 to 6 degrees Celsius, the same today as when Tucker's sonar made its first pass across the surface in 1968. The peat particles suspend in the column below 30 meters in the same density, absorbing the same proportion of any light directed into the water. The sediment floor lies undisturbed at depth, the same sediment that has accumulated since the glaciers retreated and the basin filled, fine and cold and still. The Loch Ness Investigation Bureau's archive, accumulated across 10 summers of systematic watching, documents a decade of human attention directed at the water's surface, the observation logs in careful handwriting, the film material from the camera volunteers, hours of surface footage in which the light changes and the weather moves and the water remains itself, occasionally producing events that the observer noted and that on review did not yield to identification. That archive is the record of what a decade of serious watching produced. It documents the effort, it documents what was seen, it documents in its accumulated careful entries the limit of what surface observation could establish about the water below. Somewhere in the cold, deep section of the loch's central basin, if Tucker's 1968 contacts were biological, something moved at 17 kilometers per hour through water that the sonar could measure and the human eye could not reach. Somewhere in the same basin, if the Operation Deepscan contacts were biological, 3 objects larger than any documented fish species in the loch moved below the survey flotilla as it crossed the water's surface in formation. Neither of those conditional propositions has been confirmed or eliminated. They sit in the record as what the instruments found, bounded by what the instruments could establish, held open by what the instruments could not. The research vessel from the 2023 search event returned to shore after its survey passes. The sonar equipment was recovered. The data was downloaded. The operators noted the unidentified contact in their logs and indicated that the material would be reviewed further. The loch at the surface, as the boat moved back toward the dock, was quiet in the way it is always quiet, dark and wide, and carrying the reflections of the hillsides on both banks, the surface suggesting nothing about what lay below it. The depth beneath the hull was the same depth it had always been. The water was the same temperature. The peat particles moved in their slow suspension through the column below. The contact at 9 meters depth remained in the data file, logged, time-stamped, and unresolved. The high concentration of eel DNA in Gemmel's samples remained in the digital archive at the University of Otago. The anomalous value at each sampling location recorded alongside the values from over 3,000 other species. The question it raised about the size of individual eels still present in the data without an answer. Tucker's published findings from 1968 remained in the back issues of New Scientist, the context described in the careful language of someone who understood that what his instrument recorded was not the same as knowing what had produced the recording. The loch does not resolve. It receives the instruments that are brought to its surface, and it returns measurements that stop at the boundary of what measurement can establish. The sonar pings descend into dark water and return what they return. The sample bottles are drawn up from depth and labeled and sealed and sent to the laboratory. The observation logs accumulate their careful entries through the summer seasons. The data files are time-stamped and archived and remain open. The The loch continues in the Scottish Highlands as it has continued since the ice retreated and the Great Glen Basin filled, long and narrow and cold, holding whatever it holds in water too dark to see through, too deep to be fully mapped, and too large, still, to be certainly accounted for by any instrument that has been brought to bear on it. The 2023 sonar image sits in a recording system somewhere, a shape at 9 meters depth, a date in September, a position on the loch noted and saved. The analysis is not complete. No identification has been published. The shape in the data is still there, quiet and specific, a measurement from a real instrument at a real depth in a real body of water, waiting in the file for a description it has not yet been given. The loch outside the recording system is unchanged around it, the surface still and dark, the depth below still and cold, the water moving in the slow deep currents that carry whatever is carried through the basin, unmeasured, from one end of the long stone fracture to the other. Approximately 10,000 years ago, the last of the glacial ice pulled back from the Great Glen, and the long basin it left behind began to fill. The process was slow. Water gathered in the fracture from rainfall and runoff, from the rivers feeding in at both ends, from snowmelt off the highland ridges above, and the loch grew deeper and darker and colder over centuries until it reached something close to what it is today, a body of fresh water 37 kilometers long, its floor lying in some places more than 200 meters below the surface. Its deep interior cold and still and almost entirely without light. That is where any examination of what the loch might actually hold has to begin, not with photographs or newspaper reports, or the long history of what people said they saw from the shore road above, with the geological fact of how old the basin is and what that age rules out, and what it leaves standing. The plesiosaur hypothesis has a long and widely circulated history. It rests on a recognizable shape, the long neck, the small head, the broad body, a silhouette that attached itself to the idea of Loch Ness in the early decades of the 20th century and never entirely left. The difficulty is that plesiosaurs were marine reptiles of the Mesozoic era, and the Mesozoic ended approximately 66 million years ago. Loch Ness is 10,000 years old. The gap between those two figures is not a gap that any lineage of air-breathing reptile could bridge through continuous habitation of the basin, because the basin did not exist for 65,990,000 of those years. The ice was there, the rock was there, the water was not. Any plesiosaur-like creature inhabiting Loch Ness today would need to have arrived in the loch from somewhere else after the ice retreated through the river systems that connect the basin to the sea, and it would then face the loch's year-round water temperature, which holds at 5 to 6 degrees Celsius at depth, regardless of the season above. That temperature is severe for an air-breathing reptile. It would need to surface regularly to breathe. It would need to sustain a body large enough to be visible from the shore road at a distance. And it would need to do both of these things in a body of water that has been increasingly observed and monitored for almost a century, without producing a single piece of physical evidence, no body, no bone fragment, no confirmed biological sample that has survived scientific analysis. What the geology establishes, plainly and without ambiguity, is that the plesiosaur hypothesis cannot survive the age of the basin. That is not a dismissal of the sightings themselves, of which there are many, made by people whose honesty there is generally no reason to question. It is a statement about what the specific candidate explanation requires, and what the documented record of the loch's formation does not support. The sightings remain, the explanation does not fit them. Other candidates fit better, or at least more honestly. The Wells catfish, Salurus glanus, is a large predatory freshwater fish documented at lengths exceeding 2.5 meters and weights of over 100 kilograms in European river systems. It is a species known to create significant surface disturbances during feeding, and when rolling near the surface or breaking through it, can produce profiles that read from a distance as humped, dark, and fast moving. Naturalist Jeremy Wade and other researchers have raised it as a candidate for a portion of Loch Ness sightings, and the hypothesis has a reasonable biological basis: large individuals, surface behavior, compatible habitat. The difficulty with the Wells catfish is that no confirmed specimen has been captured in Loch Ness. The species has been introduced to some British waterways, but its presence in the loch specifically remains undocumented. It is a candidate species that fits the observed behavior in some accounts and fails to explain others, and without a confirmed specimen from the loch, it remains a reasonable hypothesis rather than an established fact. The Greenland shark, Somniosus microcephalus, is a larger and perhaps more dramatic candidate, documented at lengths approaching 6.5 meters, adapted to deep cold water, known to inhabit Scottish coastal ranges in the North Atlantic. The scale fits. The cold water temperature fits. The problem is that Greenland sharks are marine animals with osmoregulatory systems evolved for saltwater, and Loch Ness is a landlocked freshwater loch connected to the sea only through river systems whose gradients and flows are not consistent with a large shark moving inland and sustaining itself in fresh water over any period of time. Biologist Neil Clark of the Hunterian Museum in Glasgow proposed the hypothesis, and it has a certain geological plausibility in the broadest sense. The loch was briefly connected to the sea during the post-glacial period, and marine species could theoretically have entered the basin before it became landlocked. But the osmoregulatory obstacle is considered formidable enough under current scientific understanding that the Greenland shark remains in the category of intriguing but highly improbable candidates, held there not by dismissal, but by the weight of what the biology requires. These hypotheses, the catfish, the shark, share a quality that distinguishes them from the plesiosaur. They are biologically possible in principle, even where unconfirmed in practice. They describe real animals with documented sizes and behaviors that are at least partially compatible with the loch's conditions and with some portion of the recorded sightings. They fail on confirmation, not on fundamental biological implausibility. That distinction matters when thinking carefully about what the loch's conditions actually support and what they rule out entirely. There is another category of explanation for Loch Ness sightings that does not involve large unknown animals at all, and it is worth sitting with that category carefully because it accounts for more of the documented reports than any single candidate species. Researchers including Ronald Binns, Adrian Shine, and Joe Nickel have spent years examining specific sightings against specific environmental and biological conditions, and what that examination has produced is a set of well-documented natural phenomena that to an observer on the shore road above the loch without prior knowledge of what they were looking at could read convincingly as something large and anomalous moving through or near the surface. Eurasian otters, Lutra lutra, are present in the loch and its surrounding waterways. A mother and cubs moving in single file across the loch's surface can produce a series of small humps visible from the road above, with the gaps between the animals creating the impression of a larger single creature moving in an undulating pattern. In low morning light, with water that absorbs rather than reflects, the profile can be genuinely difficult to read at a distance. The wakes of the animals cross and merge. The bodies rise and fall. By the time the observer has registered the shape and reached for a camera or binoculars, the animals have dived, and the surface closes without leaving anything to point at. The account that results is honest. The observation was real. The interpretation of what produced it is where the error enters. Waterlogged timber produces a different kind of sighting. Scots pine and other highland species grow close to the loch's shores, and fallen trees enter the water regularly. A waterlogged section of timber, saturated to near neutral buoyancy, can rest on the sediment floor for years before trapped gas from decay causes it to rise suddenly and briefly toward or through the surface. The emergence can be dramatic, a dark, rounded hump breaking the surface at speed, leaving a significant wake before the gas dissipates and the timber begins to sink again. Adrian Shine, who has spent decades investigating the loch, examined a section of waterlogged Scots pine that had surfaced near Invermoriston. The timber was dark and sodden, and in the moment before it settled lower in the water, it presented a profile that was genuinely difficult to distinguish at a distance from something animate. It sank. The surface closed. The incident lasted perhaps 30 seconds from emergence to disappearance, which is entirely consistent with the duration of many reported sightings. The Seisha is perhaps the most remarkable of these phenomena, because it involves large-scale movement of the loch's surface that has no visible cause. A seisha is a standing wave generated by pressure differences at depth, wind or atmospheric pressure variations that set the water in the basin oscillating on a long, slow rhythm. In Loch Ness, seiche events produce large, smooth rollers that can move along the surface from one end of the loch to the other with no wind present to account for them, the water rising and falling in waves of considerable size and apparent purpose, as though driven by something beneath rather than above. An observer unfamiliar with the phenomenon, watching these rollers move steadily up the loch on an otherwise calm morning, is observing something genuinely unusual, the surface disturbed by a force entirely beneath it, the disturbance larger and more sustained than any fish or group of animals could produce. The seiche does not look like nothing. It looks like something large and purposeful moving at depth, and the impression it creates has been documented carefully by researchers who have correlated reported sightings with atmospheric and hydrological conditions on the dates in question. None of this means every sighting at Loch Ness is explained. The misidentification phenomena account for a portion of the reports, probably a significant one, and the honest acknowledgement of that is part of what makes the remaining cases interesting, rather than less so. What cannot be accounted for by otters or timber or siege is what remains genuinely open, and there is enough of it to make the question worth holding. Professor Neil Gemmell of the University of Otago led an international team in 2018 conducting environmental DNA analysis of water samples drawn from multiple locations and depths throughout Loch Ness. The methodology of eDNA analysis rests on the fact that every living organism sheds genetic material into the water around it: cells, scales, mucus, fragments of tissue, and that genetic traces from this shedding can be detected, amplified, and identified from water samples using sequencing technology. A sample bottle drawn up from depth near the center of the loch contains, in the dark, cold water inside it, genetic information about what has been living in and moving through that part of the basin. The sample itself is invisible to the eye. The contents require laboratory equipment to read, but they are there. Gemmell's team identified traces from over 3,000 species in the samples they collected from Loch Ness. The range was broad: bacteria, fungi, invertebrates, fish, mammals. What they did not find was any genetic evidence of reptiles or sharks or anything that might correspond to a plesiosaur-like animal. The plesiosaur hypothesis, already under significant geological pressure, found no support in the eDNA data. The Greenland shark hypothesis found no support either. The species that might correspond to the various large creature candidate explanations were simply not present in the genetic record drawn from the water. What was present, in an amount that registered as unusually high relative to other freshwater bodies of comparable size, was eel DNA. European eels, Anguilla anguilla, are documented inhabitants of Loch Ness, and their genetic material was found throughout the samples. The concentration was notable. Gemmell stated publicly, following the analysis, that while he could not confirm the presence of giant eels in the loch, the unusually high concentration of eel DNA found in the samples was consistent with an eel population that included very large individuals, eels that, if they had failed to migrate and continued growing for decades beyond their expected lifespan, could potentially reach several meters in length. That statement was careful. It did not assert the presence of giant eels. It noted that the eel DNA data was compatible with their presence, while acknowledging that other explanations for the elevated concentration were possible. The European eel is an animal with a life history unusual enough to be worth dwelling on for a moment. It is a Catadromous species, born in the Sargasso Sea, carried on ocean currents to European coasts, then ascending rivers and entering freshwater systems where it may live for decades before eventually returning to the sea to breed and die. The journey from the Sargasso Sea to the Scottish Highlands is not a short one, but eels make it, and they have been making it for a very long time. An eel that entered Loch Ness from the River Ness and settled in the deep cold water of the basin might, under the right conditions, fail to receive or respond to the hormonal triggers that normally initiate the return migration. It would simply remain, and it would continue to grow, because eels do not stop growing when they stop migrating. They grow more slowly, but the process continues. An eel that had been in the deep water of Loch Ness for 30 years, or 40 or 50, would be an animal of considerable size. An eel of that age in water that cold, moving slowly through the sediment floor of the basin in near total darkness, shedding its genetic material into the water column above it, would be precisely the kind of animal that Gemmell's elevated eel DNA concentration might reflect. What such an eel would look like at the surface is a reasonable question. A very large eel moving through shallow water near the shore, or ascending toward the surface for reasons that eels do occasionally ascend, following prey, responding to temperature gradients, moving from one part of the basin to another, would present a long, dark, sinuous profile, dark against dark water, and might produce a wake and surface disturbance consistent with something large and animate. The neck and head profile of the most famous photographs is not easily reconciled with eel anatomy, which lacks the obvious neck structure of the plesiosaur silhouette. But other reported sightings, those describing a long, dark, rolling shape at or near the surface, without a distinct head, moving with what observers described as a smooth, undulating motion, are not incompatible with a very large eel moving through the upper water column. The accounts in the biology do not align perfectly. They do not need to align perfectly to make the hypothesis worth considering. The eel hypothesis carries a quality that the plesiosaur does not, and it is worth naming that quality plainly. It requires nothing impossible. It requires only that some eels in a cold, deep, food-rich freshwater loch in the Scottish Highlands lived much longer than eels typically live, and grew much larger than eels typically grow. That is not a claim about an unknown species or a relict population of prehistoric creatures. It is a claim about the outer edge of what a known species, under unusual conditions, might do. The outer edge of what is known is not the same as the impossible. It is simply the far end of the documented range, where measurements become sparse and the record thins out, but does not stop. Adrian Shine has spent more years examining the biology of Loch Ness than almost anyone. The loch he describes in his most careful accounts is not a body of water that hides a large unknown predator in its depths. It is a body of water with a relatively low productivity. The peat acidity reduces the light available for photosynthesis, which limits the plant matter at the base of the food chain, which limits the size of the fish populations available as prey. A very large animal living in the loch would face real constraints on what it could eat and in what quantities. The loch is not, by the standards of productive freshwater systems, a rich feeding ground. What it offers is cold, stable conditions at depth, a floor undisturbed for thousands of years, and considerable volume. What it does not offer is an abundance of prey, large enough to sustain a population of very large animals. This is a constraint on the plesiosaur hypothesis, and on most large predator hypotheses, that is separate from the geological and thermal objections, but equally important. A breeding population of large unknown animals would need to eat. The loch's documented productivity does not obviously support that requirement. A single very large eel, or a small number of very old eels, faces a less severe constraint. Eels are not apex predators, requiring large prey. They are opportunistic feeders capable of sustaining themselves on invertebrates, small fish, and organic material. A large eel in a cold, deep loch with a sediment floor rich in accumulated organic matter has access to food sources that do not require a productive open water fish population. The biology fits in a modest way, where the biology of larger and more dramatic hypotheses does not. None of this is confirmation. It is the careful end of the range of what the evidence supports, held at the distance from certainty that the evidence warrants. Gemmel's eDNA data sits in the University of Otago's research archive, time-stamped and accessible. The eel DNA concentration noted as anomalously high, the data available for further analysis by any team with access to it and reason to examine it. The file is not closed. The question it contains is not answered. It records what was found in the water of Loch Ness in 2018, and it leaves open what that finding means for the largest scale version of what it might reflect. There is something worth holding about the loch itself, separate from any candidate species or explanatory framework. The basin is old. The water is cold and dark and deep. The sediment floor has been accumulating in stillness since the ice retreated, and whatever rests on that floor or moves through the water above it does so in conditions that resist observation with a consistency that is not mysterious, simply physical. Below 30 meters, peat particles suspended throughout the water column reduce visibility to near zero. An artificial light lowered into that darkness scatters back within a few meters. The sonar instruments that have traced the basin's contours have measured depths and recorded contacts, and produced data that has, in some cases, resisted easy explanation, but the instruments cannot see into the water any more than a human eye can. They can measure. They cannot observe. The distinction matters. Measurement tells us the contact is there, at depth, moving at a particular speed. It does not tell us what the contact is. This is the condition of the loch, as it has been since the first sonar equipment was lowered into it. Not mysterious in a dramatic sense, not impenetrable in a way that implies concealment, simply large enough and dark enough and cold enough that instruments capable of measuring it have not yet been capable of resolving its contents at the level of detail that would answer the question of what lives in its deepest water. The question is an honest one. The loch is a real place. The measurements are real measurements. What remains unknown about the basin is unknown not because it is inherently unknowable, but because the tools for knowing it precisely have not yet produced a definitive answer, and the water continues to hold whatever it holds. The eel DNA data in Gemmel's archive is perhaps the most interesting thread currently available in that long and patient inquiry, not because it proves anything, because it is the one piece of evidence gathered from the water itself, not from the surface, not from a photograph, not from a sonar trace, but from the actual molecules present in the water column at multiple depths and locations that points in a direction worth following. The European eel is a real animal with a documented presence in the loch. The concentration of its genetic material in the samples was high enough to register as anomalous. What that anomaly reflects, whether it represents a large number of normal-sized eels or a small number of very large ones, or something else entirely in the distribution of the population, has not been established. The data is compatible with giant eels. It is also compatible with other explanations. Gemmel himself was clear about this. He did not announce a discovery. He noted that the data did not rule out what it did not rule out, and that further research into the eel population of the loch was warranted. That quality of careful openness, the willingness to follow the data to the edge of what it establishes and stop there without filling the remaining space with either certainty or dismissal, is what the most honest investigators of Loch Ness have consistently demonstrated, and it is what the loch itself seems, in its way, to require. The basin resists the strong claim. It resists the definitive answer, not because it is enchanted or protected or impenetrable in any supernatural sense, because it is very large and very dark, and the instruments available for examining it have so far been adequate to measure its depths, but not to resolve the question of what swims in them. What the loch offers in the end is something quieter and more durable than a monster.